In this video, we will be practicing in molarity calculation, the most common unit used to determine the concentration of a substance. So starting with number 1, which is from the book of school, we are asked to calculate the molar concentration of ethanol in an aqueous solution that contains 2.30 grams of C2H5OH in 3.50 liters of solution. So we are asked to get the molar concentration. So molar concentration is simply molarity, right? Or M. And we know that molarity or M is simply mole of the solute over liter of the solution. Okay, so we were given the mass of the solute, which in this case is C2H5OH. So this is the chemical formula for ethanol, C2H5OH. But we want to get the mole of the solute. So we need to convert this mass, which is given in the unit of grams, to mole. Thus, we need its molar mass. And we were also given the liter of the solution, so this is good. But we need to find the mole. So you may use your periodic table, but I have a trick. But this is actually an easy one because we are only using organic elements such as carbon, hydrogen, oxygen, and oftentimes there's also nitrogen as well. So as you may or well known that carbon, hydrogen, oxygen, nitrogen are common organic elements. I mean, there is also phosphorus and sulfur, but these are the most common ones. Oftentimes, students just memorize the molar mass of these elements, so they don't need to look back and forth into their periodic table, because and it's easy. So first, let's start with hydrogen. Okay, H. Hydrogen, we all know that is just 1.01, or you can just input 1 gram per mole, or just 1 G per mole. Okay, and next would be carbon, which is very common as well. That is 12.01 gram per mole, or just 12. Okay, just memorize this 112 for hydrogen and carbon. And next would be oxygen. Oxygen is around 15.99 grams per mole, or just simply memorize it as 16 grams per mole. Okay, and last would be nitrogen. Nitrogen is not in the problem, but let's just memorize it for the sake. So nitrogen is 14 point, I think, 1 G per mole. These are approximate, okay? Or it can be just simply 14 grams per mole, okay? So you can memorize this instead of looking back and forth into your periodic table, okay? So now that you're familiarized with this, we can solve for the molar mass of ethanol. So ethanol is C2H5H. So that's 2 carbons. So there are 2 carbons. So 12, we have 12 G per mole for carbon times 2. Okay? Follow this. Plus 5 hydrogen. 1, which is 1 grams per mole times 5. Then 1 oxygen, which is 16. 16 plus another 1 from hydrogen plus 1. So that it, so adding these would be the molar mass of ethanol, which is approximately 46 grams per mole. So you have calculated the molar mass of ethanol without looking your periodic table. So just simply memorize this, okay? Memorize. Or you may use your periodic table to make sure that this is a more faster and efficient way to solve this type of problem, especially if it has a time limit, right? So now you got the molar mass. We can use this to calculate for the molarity. Okay, so let's change to white. Okay, so solution. So you've got the mass. Let's start with the mass, which is 2.30 grams. You have 2.30 grams ethanol. Okay, and using the molar mass, you know that 1 mole of ethanol is 46 grams, right? Now you had the mole, now you need the liters, and it is given. You have 3.50 liter solution. So 3.50 liter. We're simply following this formula, right? Mole of the solute over liter of the solution. Okay, you can cancel this, and now you get the mole of the solute, which is ethanol, and the liter of solution. Now you can use your calculator to solve the molarity of ethanol. And that will be 0.0143 molarity or mole per liter. Okay, 0.0143. So that's it. You can use the molar mass and simply use the given liter of solution. Right? So, okay, so for the next question, calculate the molar concentration of methanol or CH3OH in a solution that contains 1.60 grams of methanol dissolved to make a 2-liter solution. Okay, so we were also given the volume of our solution, which is in liter. Right, so remember that molarity is mole of solute and liter of solution. So this is good already. Now we want the mole of solute. In the same case as number 1, were also given the mass of the solute. Now we need to calculate for its mole, right? So using the molar mass that we have memorized from number 1, we can solve for the mole of methanol. So methanol is CH3OH. So remember this one, okay? Oftentimes, this chemical formula is not given. They just say methanol. And you need to know what's the structure of methanol. And this is the structure. Okay? And this is like an introduction to organic chemistry. This is very easy to memorize. But let's focus here in solving. Okay, so we have 1 carbon, so carbon is 12, right? Plus 3 hydrogen. Hydrogen is 1 grams per mole plus 1 oxygen and another 1 hydrogen. Okay, now by adding this, we can solve for the molar mass of methanol, which is 32 grams per mole. Okay, now that we have the molar mass of ethanol, we can solve for its molarity in a 2-liter solution. So let's use the given mass. So 1.60 grams of methanol times, okay, we know that the molar mass. So 1 mole of CH3OH weighs 32 grams. Now, using the volume of the solution, we can solve for the molarity, which is 0.02 molar. Okay, so this is the molarity of the methanol solution. So next, a solution contains 5.75 grams of propanol in 1.25 liter of solution. Calculate the molarity of. You can pause the video and solve it yourself. Just like the previous questions, we were given the mass of the solute but not the mole of the solute. So we must use, or we must find its molar mass. So propanol, which is our solute here, is C3H7OH. So solving its molar mass, we have 3 carbon. Carbon is 12. 12 times 3 plus 7 hydrogen. Hydrogen is 1, so 1 times 7 plus 1 oxygen, which oxygen is 16 grams per mole, and 1 hydrogen, which is 1. So solving this, propanol is 60 grams per mole. Now we can use this information to solve for the molarity of the propanol solution. So likewise, let's start with the given mass. So 5.75 grams times, so 1 mole, okay, this is propanol. 5.75 grams of propanol, 1 mole of propanol weighs 60 grams. Okay, we have found it here in its molar mass. And we were given the volume of the solution, which is in liters, 1.25. 1.25 liters. Okay, now we can cancel the grams. And we're left with mole per liter, which is molarity. And using your calculator, the concentration would be 0.0767 molar. Okay, so that is the concentration or the molarity of propanol. Next, an aqueous solution contains 420 milligrams of acetone in 250 ml of solution. Determine the molar concentration of acetone. Okay, like the previous question, we were given the mass, but this time it's in different units, so it's in milligrams, right? And the volume as well is in different unit, it's in L. So we need to convert this to liters, and this 1 grams, then to mole, right? Because remember, molarity is mole of solute over liter of solution. Okay, remember this. Next, so we must solve first the molar mass of acetone. Okay, so acetone is actually a very common chemical. It looks like this. Okay, CH3, CH3. Okay, the chemical formula is C3H6O, and using our approach from the previous question, we can solve for the molar mass. So carbon, so there are 3 carbons, so 12 times 3 plus 6 hydrogen. So 1 gram per mole for 100 grams, so there are 6. So times 6 and 1 oxygen. That would be 16 grams per mole. So solving, the molar mass of acetone is 58 grams per mole. Now that we have the molar mass, we can use this to solve for the molarity of the acetone solution. Okay, so starting with the given mass. So let's always start here for the given mass of the solute. 420 milligrams of acetone. So C3H6O. We know that 1000 milligrams is 1 gram. Okay, and we know based from what we found in its molar mass, 1 mole of acetone is 58 grams. Now we get the mole of the solute. We need the liter of the solution. Okay, but it was given in ml. So let's convert that to liters. So 1000 ml is 1 liter. Okay, always remember. Okay, remember because this is pretty common, especially when there is milli. Okay, so the milli form is 1000 and it's non-prefix form. What do I mean by non-prefix form? Let's say milliliter. So the non-prefix form would be in liter. Milligram. So the non-prefix form would be gram. So its non-prefix form will be 1. Okay? So 1000 milli will be equal to 1 something. Okay? So for instance, 1000 ml is 1 liter. Okay? I hope you get that. Now we can solve for the molarity since we can cancel this and then this. So we're left with mole over liter, right? Mole over liter. Okay. So solving, the molarity of the solution is 0.02896 or just 0.0290 molar. Okay. That is the concentration of our acetone solution in this problem. Okay, so it's longer than the previous question because the starting units are not in grams and not in liters. Okay, so this may be your problem is the conversion. So oftentimes students get wrong in the conversion process, even though they know what or how to solve the problem. The unit are wrong. Okay, so you must look at the problem more carefully. Next, and this will be the last question. A student dissolves 8.90 grams of sodium acetate trihydrate or CH3COO and A3H2O to prepare 500 ml of solution. Calculate the molarity of sodium acetate or CH3COO and A in the solution. So in this problem, we have the hydrate and we have the non-hydrate form. And we want to solve for the molarity of the non-hydrated form, okay? Not the trihydrate. So this needs stoichiometry, but this is simple because, okay, I'm gonna show you later on. This is pretty simple. So let's start by the molar mass, okay? So the same process. So we started with sodium acetate trihydrate. So of course, let's start with that. Sodium triacetate trihydrate is in this formula. So starting with the molar mass. So first, we have 1 carbon plus 3 hydrogen. So 1 hydrogen is 1 grams per mole times 3 plus another carbon. And we have 2 oxygen here. So 1 oxygen is 16 grams per mole times 2. And we have sodium. Sodium is, okay, if this time you should look at your periodic table. So sodium is approximately 23 grams per mole. I believe it's around 22.9 something. But 23 is a good approximate. Okay. Plus water. So you get 3 H2. So you get 3 times 1 water. Okay, 1 water is 1. Then you have 2, so times 2. Okay, that would be 136 G per mole. Okay, so this is the molar mass of sodium acetate trihydrate. Okay, now we can use this one to solve for the molarity of sodium acetate. Okay, so likewise, let's start with the given grams. So we have 8.90 grams of sodium acetate trihydrate. So I'm just gonna SAT, so sodium acetate trihydrate. Okay, and we know that its molar mass is 136 grams per mole. So 1 mole of SAT weighs 136 grams. Okay, now we want to determine the molarity of sodium acetate, not sodium acetate trihydrate. So using its stoichiometric values, or basically its proportion to one another. Okay, so I'm showing you this. So 1 mole of SAT, so SAT, sodium acetate trihydrate, is basically this one, right? So let's write it in its chemical formula. CH3, CEO, Na, 3, H2O. Okay, so 1 mole of CH3COO Na times CH2O is sodium acetate trihydrate. So we want to convert it to sodium acetate. So how many mole sodium acetate in the mole of sodium acetate trihydrate? There's only one. Why? Okay, if you look at this one, sodium acetate is basically this, right? This without the water, okay, without the trihydrate. And we were asked how many sodium acetate in sodium acetate trihydrate. So based in its chemical formula, there's only one, okay? So there's only one of this in this. That's okay, okay? So for instance, let's say we want to get water. So how many mole, let's say, in 1 mole, this is an example only, okay? So 1 mole of CH3COONA GOH2O, and we want to convert it in moles of water. So how many moles of water do we need? There's 3, right? Because there's 3 H2O. So we need 3 mole of H2O. So just like that. So this is simply a 1-to-1 ratio. Okay, this is just an example. You have to get it. Okay, so we can now use the given volume. So the volume is in ml. So we need to convert this into liters. So 500 ml. So convert this to liters. So 1000 ml is 1 liter. So solving, oh, okay, we are left with what? Mole of sodium acetate over liter. So now you can find the molarity of sodium acetate. Okay, solving, then that would be 0.131 molarity. So that is the molarity or molar concentration of sodium acetate in the solution. Okay, so that's it. Thank you for watching. So if you want me to solve questions, chemistry questions, you can comment down below and I can make a video out of it. Or if you have any recommendations on what I should teach in line of chemistry, I would just comment down below. Thank you for watching and don't forget to like and subscribe.